everyone, and welcome to Chocolate, a Sweet Science from the Kansas State Food Science Institute. Today we'll be talking about chocolate and some of the science behind it. First, let's go over a brief history behind chocolate. It's hard to tell exactly when chocolate was first discovered, but the general consensus is sometime between 1900 and 500 BC, ancestral Mesoamericans discovered how to make chocolate from cacao beans, and then around 250 AD, the Mayans began making a chocolate beverage. It's a lot different than the bars we see today because it's an unsweetened beverage made from the cacao beans. And then shortly after, the Aztecs followed with chocolate drinks sweetened with honey. In the 1500s, the Spanish colonized South America and chocolate was brought over on ships back to Spain. They began adding sugar to sweeten the drink. At first, only the ruling class could afford chocolate, but then it spread to the common people. It spread like wildfire to Europe and North America during the Industrial Revolution when it became easier to produce with machines. 1847 was when the first solid chocolate bar was made by adding cocoa butter back into the chocolate. And then Hershey's opened their first factory in 1894. The newest sort of advance in chocolate making is artisan chocolate that we see today, with the beans carefully selected by growing regions to get a specific flavor. So let's take a look at those growing regions. Here's a map of where the cacao beans are grown in the world. And you can sort of see a pattern here. It's in this strip near the equator. That's because these cacao beans need the warm, humid climate to grow. So the darker sections are where chocolate is grown more, and the lighter sections are where less chocolate is grown. We have South America with Colombia, Ecuador, the Dominican Republic, Brazil, Peru, and then there's also some production in the middle of Africa with Ghana, Nigeria, Cameroon. And then we also see some in South Asia with Indonesia and Cambodia. So let's watch a short video about a smaller chocolate factory and how the chocolate making process goes.
I'm Nate Hodge, the head chocolate maker and co-founder of Rocca Chocolate, and we're at our chocolate factory in Red Hook, Brooklyn. So the cacao pods are cut open, and there's a mixture of fruit surrounding the seeds of the cocoa tree. Those are scooped out and generally put into sacks so that they can be taken somewhere to be fermented. This is a repurposed juicer that has a custom casing and set of blades for cracking the cocoa beans. We use them for separating the shell from the nib, like this, just pure nibs. And what we want to do is start to refine this so that we can turn it into ooey gooey, shiny, rich chocolate. These are like Indian spice grinders that are used for chai, curries. These have been repurposed for cocoa. We'll run it overnight and then we'll add sugar in the morning. This is after it's gone through the roller mill behind us. This is going to get thicker and thicker and thicker, and then eventually you'll start to see like sugar granules coming out, and then the machine will start grinding the solids. You want to recoat all the particles in fat, and you want to reshape those particles. So since it's coming through here in a really tight space, it's flattening the particles, and that's great. We want small particles, but what we also want are particles that are rounded into a pearl shape so that it rolls off your palate instead of like sticks to it. So they're going to run this through 3 times, and by the end, it's just going to be like a big knot of chocolate. So after the chocolate has been massaged and aerated, then we're going to do this, which is the process of tempering the chocolate. So it's aligning the polymorphic crystals in the fats and the solids so that they all harden at the same temperature. Cocoa bean is roughly 50% cocoa powder, 50% cocoa butter. Because we have 50% essentially of pure fat, we like to play with that fat. Hector's steeping chanterelles in cocoa butter. In the holding tank, we'll add a lot of the other flavoring, deep herbs or teas. We really want that like incredibly silky texture, and being able to flavor the butter and then add that back in, it doesn't affect the texture. So then we'll roll the racks into this box. Humidity and chocolate don't mix, so it goes in there at like a dry 55 degrees for the chocolate bars to set perfectly. Rolled out, stacked up over here, put into these white bins. And then this is our wrapping machine. We're doing like 1,600 to 2,000 bars a day.
Oh, yes.
So that was super cool, right? Now that we've seen the process, let's look at the ingredients in a typical milk chocolate bar. Here's a Hershey's bar wrapper. And if we look at the ingredients, you see milk chocolate followed by sugar, milk, chocolate, cocoa butter, like we saw in the video, lactose, which is just milk sugar, milk fat, and then soy lecithin. It's an ingredient that is used in a ton of different things, so you might have seen it before and wonder what it is. Let's investigate a little more. Soy lecithin is an emulsifier. An emulsifier stabilizes liquids that don't normally mix. If you've ever mixed oil and water as a science experiment, you know that you can shake it as much as you want and stir it as much as you want, but it will never stay mixed. And that's where the emulsifier comes in. It helps to improve the interaction between the two types of molecules so that they can mix. Here's some common emulsions that you might be familiar with. Milk, ice cream, salad dressing, mayonnaise. All of these products have fat and then other ingredients that don't commonly mix with the fat, so water or sugar. And we add in the emulsifiers to help them mix. Lecithin can be found in soybeans and in egg yolks. And this diagram right here illustrates it a little bit more. We have the continuous fat phase. And when I say continuous, I just mean that the background, the orange part, is the fat. And the sugar particles are sort of floating in the fat. The lecithin, the little red spaghetti noodles, they bind to the sugar and surround it to help it mix in with the fat and help it sort of float as an emulsion. Now I'll show you a demonstration of what an emulsifier does. Hi everyone, thanks for joining us for Chocolate, a Sweet Science. This is going to be our lecithin demonstration. What we have here is a beaker with oil and water, and this beaker also has oil and water, and we're going to see what happens if we add lecithin. Let's get a close-up shot. Okay, so what I've got right here is some lecithin. And we're going to add it in. We're going to stir both so we can see what happens. Okay, so let's add the lecithin. Give them both a mix and see what happens. Right away you can see that the oil and lecithin mixture is a lot more mixed. And pretty quickly the water separates out, while the oil, water, and lecithin mixture the oil stays mixed in with the water. And you can see that it sort of still separates out here a little, but I'll zoom you in a second because it's not perfect, but what you can see is that this section here is yellow from the oil, whereas it's clear on the water variation. So let's zoom in a bit. You can see the oil is sort of mixed in with the water, and over here it's pretty clear. So there you have it. This is an example of what lecithin and emulsifier can do to help emulsions like oil and water mix. So another interesting aspect of chocolate is the tempering process and what it does for the quality of the chocolate. We saw it a little bit in our video, but I think it'd be interesting to talk about it more. So tempering is a method of cooling the melted chocolate to get the qualities that we want. We have a comparison on the right here, and the chocolate on the left is tempered. This is what we want to see in a high quality chocolate. It's glossy, it's hard, it snaps when broken, and it doesn't easily melt. Then the untempered chocolate is on the right. You can see it's a bit more dull, it's not shiny, it's kind of streaky, and you can see the fat bloom there. That's the grayish part. That discoloration doesn't mean that it's spoiled or gone bad. It just means that the fat has come to the surface by melting slightly. It doesn't look appealing, but it's still perfectly safe to eat, though it may negatively impact the flavor or texture. So here's an illustration of what is going on when we are tempering chocolate. First, the untempered chocolate is various shapes and sizes of crystals. They're all over the place and not arranged nicely. When we melt the chocolate, we destroy all of the crystals and break it down into this sort of base structure where it's all one type and size of crystal. And then when we let the chocolate harden, it's allowed to harden at a very specific temperature between 90 and 92 degrees Fahrenheit. So it starts to link up together into really nice, stable crystal structure. And the structure allows the chocolate to have all the physical characteristics that we like. Now we're going to hear from a K-State alum, Heather Ahrens. She graduated from K-State with a master's in food science in 2018, and now she works with Hershey's. Heather is a senior research scientist in chocolate product development, and she's going to answer some questions for us about what it's like to work in food science.
So what do you do in your position with Hershey's?
So I work in chocolate product development for our seasonal variety and our grocery group. So our seasonal products being all the seasons, the holiday, Valentine's, Halloween, and variety brands being like the Cadbury brands and brands that are not the Hershey and Reese and Kit Kat brand, and then also our baking chips and our syrups.
Mm-hmm. And so what does a typical day look like for you? What are some tasks that you might do?
So I would say no day is really typical, which is fun, which is what
Sure.
one thing that I like about it. So, but a lot of times it's we're working on benchtop formulas. That I'm in the building today making samples for one of my holiday 2021 projects. So doing a lot of formulations, tastings, making different iterations, tweaking formulas, and then obviously the day-to-day meetings of the various projects on, capabilities, working a lot with actually manufacturing and what we call our supply chain folks to make sure that we can make products in the plants, because just because you can make a benchtop doesn't mean you can scale it up in a plant environment.
For sure. And so for our students, when you say benchtop, like benchtop formulations, what does that mean? So we would work in our lab and we would maybe I'll use syrup as an example because it's a good example, like where you can make one bottle of syrup, which is basically 750 grams. And then once we figure out formulations and we would move it to our pilot plant facility. We have a pilot plant in our building where we can mimic manufacturing conditions, so we can make sure that processes are relatable. We can make maybe like 100 gram, 100 pound batch. So you go from like a bottle to like a couple to, maybe like 50 bottles to then a lot of times then we go to a plant to do a production trial to make sure you can make it in the plant. And our syrup line, for example, runs 54,000 pounds for a batch. So you're going from 750 grams, 54,000 pounds. Mm-hmm.
So that's why you want to make sure you get everything right in the meantime.
Sure. So you work a lot on testing the small batches first and getting everything just right before you scale it up. Cool.
Yeah, because a lot of times,
I
was just going to say that a lot of times, we might want to have I made 18 different variants of this one product at one point to do some experiments, like you add or subtract different ingredients, percentage levels and things like that. And then you finally narrow it down.
Yeah, for sure. So for our second question, what do you love about your career?
I like the creativity of food science and product development, because a lot of times we get concepts from marketing telling us how they want us to make the product, basically like what it should look like, but we have a lot of say on how to make it happen. So that's kind of the creativity. I love playing with different flavor variants of products, like trying to think of a different flavor. Like some of my coworkers had developed the lemon Kit Kats, so they would look at the different lemons and try to get those types. And there's like an apple pie Kit Kat, and they would try to make sure they work with the vendors to get like an apple pie flavor and like crust and things like that.
So it's sort of you're blending the creativity and the artistic side with the science of what can we actually
and how it can happen, and then the creativity. So and then my other favorite part is actually seeing your product on the shelf.
What do you find most challenging about your work?
I would say sometimes working with marketing you want to have deliver what they want to deliver, but sometimes the challenge is manufacturing doesn't allow that to happen, the constraints. So it's educating marketing on what you can and cannot do. And if you can't do something, not telling you can't do it, but like, I can't do this, but here's what we can do.
Yeah, you work with a lot of different people with a lot of different backgrounds.
Yes. So it's also like educating them from the science perspective, because a lot of them are not, they're business related. So not understanding your technical hurdles. So.
What are some challenges that the food science industry is facing right now? And is there anything that Hershey's is, looking at specifically?
I would say, it seems like a lot of people like with the sugar reduction and clean label. I know back in, we were doing a clean label. I developed a clean label syrup, Simply 5. It has 5 ingredients and no high fructose corn syrup, because people were hearing about the supposed evils of high fructose corn syrup. And we made that non-GMO project verified. So I think a lot of that type of thing, getting verifications, people are looking at organic products. But I've seen a lot with sugar reduction, people wanting to reduce sugar.
So for our students, what steps would you recommend to someone wanting to maybe follow a career in food science?
So my career was actually a little convoluted, but
sure, let's hear about it.
I actually was a history major at Penn State before switching to food science. So I would definitely suggest the chemistry classes and all those, the biology class, like all your science classes. And even if you would know people if people would know, people in the food industry, to reach out to them. I know we've had, high school students come and spend a day with us and get to see the hands-on with these, but definitely the networking would be a key.
Yeah, that's good that you say that. It's always, I think one thing that students really like hearing is all of the different pathways for people to end up where they are, because you think your life's going to go one way and it doesn't. For example, I'm a bakery science major, and I thought I was going to go into the industry, and now I'm a master's student. I decided to keep going to school, and I absolutely love it. So yeah, it's always cool to hear when somebody started out one path and then tried something new. And I think it's good for the students to hear, you can change your mind or have some different interests and explore what that looks like.
Yeah, I wanted to be a corporate lawyer. So I like law, and I really still find, and I love history. I do find it very fascinating. I have a minor in history. But then I got to know a little bit more about food science. Actually, when I worked as a summer job at a Godiva chocolate store, and it was a little slow at the store. Like I was just a retail salesperson there at the store, and I was reading about chocolate, and it's kind of what got me intrigued about food science, and didn't really, back in my day, really didn't know about food science. I think now people do know more about it, especially I think thanks to the Food Network.
Mm-hmm. Yeah, that's probably how I got into it. I liked to watch Cupcake Wars as a kid. And here we are.
Well, I met Alton Brown at an event, and I'm like, oh, like, I mean, he's like the food science, like because he explains science and
right. Is there anything else that you'd like to say to students interested in STEM fields or in food science specifically? Anything else come to mind? Kind of on the spot.
I think. I mean, I would definitely look into what you think will make you happy and excited, because you're going to be doing your job for probably 40 some years. So you should definitely be happy with what you are and excited about going to work and having fun. I mean, I say, when people ask me what I do, I say I play with food.
All right. So what do you do in your position? At last, the part you've all been waiting for, the chocolate tasting. So what I'll have you do is take out all of your chocolate pieces and unwrap them and place them on the chocolate mat in the right number order. And before you taste each piece, take a look at the surface. How would you describe it? The scorecard has some descriptors if you need help. Now, touch the top of the sample with your finger. Does it melt right away, or does it stay solid? How does it feel to the touch? Now break your sample in half. Do you get that characteristic snap we talked about? Or does it bend a little before it breaks? Smell the sample. What kind of aroma notes do you pick up? Finally, taste your sample. How does it feel in your mouth? How does it taste? Is it smooth, bitter, creamy? Repeat this process for all the chocolates. Happy tasting, and thanks for participating. If you have more questions, you can always reach out to the Food Science Institute at K-State.